Hello, it's Ted here once again with AINT308. This time we're looking at Assignment 2, Task 5, which is the task where we need to take a profile picture of a user on a social network and match their face in various pictures. We're provided with an example sketch which takes a picture, locates the faces in it, and extracts what's known as facial embeddings, which is facial features. So distances between the eyes, the nose, other parameters that are far beyond my pay grade. But nonetheless, they're saved into a nice object that we can refer to later. The task that we've been set is to extend this program to use the facial embeddings in that picture that we're provided, that profile picture, and match them against the different faces in an image, draw a highlighting box around the one that matches the user, and do whatever with the rest. So we're going to hop on over to the beginning of this demo, and we're going to start with everyone's favourite entrepreneur, Mr. Elon Musk. He's doing good things these days. And as you can see, the two elements we've been provided in the demo, the cascade filter has identified a face in the image, and then behind the scenes, a pre-trained neural network has identified all those facial features, the distances between the eyes, length of the nose, etc. In the demo, those facial features were just forgotten, but in my code, I have stored those facial features so we can compare them against other people in the photograph. I've also modified the code so that we can load different images in sequence. I can press X on my keyboard and it will begin to load the first, second, third image. On each picture, the cascade filter will run, identify all the faces, draw a green box around them. Once we've found a face, we can extract its embeddings as well, so we're going to end up with however many faces in the picture, a box around each of those faces, and then facial features for each of those faces. And we're going to directly compare those against those of Mr. Musk's here, and if we have a close enough match, if all of the attributes are within a certain threshold of what we've got from this picture, we're going to say, right, that's Mr. Musk, let's tag him. So if I open up my program here, I bash X, we can see that the first image loads up. So we've got 5 people in this image, opening all the wrong windows. 5 people in this image. Every single face has a box drawn around, and also, quite worryingly, the pocket of the gentleman on the right and the arm of the gentleman standing next to him. This may seem like a problem in this demo, and some would consider it a problem. However, in the context of the greater task, each of those faces would be being matched against a user profile's embeddings, which we can see has worked because Mr. Musk, who's standing tall in the centre, has been highlighted in a red circle, so his face has been within the threshold of what we expect from the profile picture. And that would have happened to every other face in the image too, so we likely, assuming they're on the social media platform, would have got a match for the other 4 people's faces. However, it is very unlikely we would get a match for the zipper and the arm. Because we wouldn't have a match, we wouldn't have a name to put against the picture. So we can just ignore those from the picture. So because they wouldn't have a username added to the list of this picture, unlike the 5 faces, we can just filter out those boxes because there's no correlation, and then we'll be left with the 5 faces. So unfortunately, as facial detection is such a complex task, there will be situations in which even random noise can appear to be a face because it satisfies those mathematical parameters which a computer looks at, unlike what we see. But the important part is Mr. Musk's face has been identified, and that is for certain. So we can move on to a second image now, load on the next one. Doesn't take too long. Excuse the little error there. That's how I fix it. Move around a bit, there we go. We can see that, again, Mr. Musk has been identified. The 3 other persons in the image also have been identified. The woman on the left seems to have her hair also identified. Again, applying this to the context, either that second match, the one that's a little bit too high, wouldn't be detected as a user, and therefore it's not a problem. We can filter it out when the usernames are assigned. Or likely it would be matched to the same user. It could be the case that it's matched to a different user, in which case it would need to be evaluated how often this happens, given your data set. Perhaps you take a smaller sample size to figure it out, and if this is acceptable. Likelihood is it will be if you're processing 10,000 photos and every 5 photos you get a double reading that's counted, you may just consider that acceptable. Pardon me. So we're going to move on to the next image. Just load that up. It doesn't take too long, it's pretty fast. As we can see, a bunch of happy people. Again, I need to move this around my screen a bit just to get rid of, fill in the picture. Quirk of recording software. A lot more faces this time, which, again, a lot more matches, but a lot more mismatches too. We can see hands several times have been identified, those skin colours. You can sort of kind of see like a sort of nose, some place where an eye could be on that raised hand on the top left. Same as before, probably wouldn't get a match, we can filter it out. Again, Elon Musk is successfully highlighted, so far the task is going fantastically, we're always getting a match to our profile. Moving on to the second last image, fill it in again. Even more faces than the last time, lots and lots of matches. This time we have no erroneous matches, which again goes to show how complex a face is and the detection isn't straightforward. We do have one clearly visible face next to Mr. Musk, which hasn't been identified for whatever reason, and then the gentleman next to him. That's likely because the shadow across his face is distorting the image enough to detect it as not a face. But sticking with the same theme, Elon Musk squared in red, so 100% hit rate on Elon Musk. And our final image, fill it in once more. Same as before. All of the faces identified. Mr. Musk standing proud in red. We're all good there. The lady on the left, her legs have been identified. Same as before, probably want to get a username match, and in that case we can filter it out. Same with the double face, same with the lady's dress on the right. So all in all, the algorithm does very well. It does take a reasonable amount of time to process a face. I believe it's about 240 milliseconds per face. So you can imagine if you had 10,000 photos, each with 5 people in, that could end up adding to a fair amount of time. It might be worth switching to a different algorithm to detect the faces. It might help speed up things, as mentioned in my report. But if you weren't in a rush, this solution would do you very well and would do a lot of the work for you. Perhaps you could build in some error detection to detect these really close faces together. Maybe if the distance between the faces is too small, you might flag up for manual review and then you can refine it further. So that's it, there we have it. Mr. Musk successfully identified in all those pictures. This has been my demo of Assignment 2 Task 5. I hope you're well, stay safe everyone, see you next time.